So good afternoon, everybody. So in today's class, we're going to be looking at trigonometry, right? For this entire class, we're going to be focusing on trigonometry. I'm going to try to finish this entire handout, right? Good morning, David. So trigonometry is a branch of mathematics that describes the relationship between angles and lengths of triangles. It is used to calculate distances in the real world when it is difficult to measure these directly. It was first used in navigation, and now it has gained widespread use in fields such as architecture, surveying, engineering, the manufacturing industry, and many other fields. So let us look at the standard notation for triangles. So in the standard notation for a triangle, we usually name the sides of, in the standard notation for a triangle, we usually name the sides that are opposite an angle by common letter that names the angle. So we know this already, right? I taught you all this already. So opposite capital B is common B, opposite capital A is common A, opposite capital C is common C. Similarly, opposite capital P, common P, capital Q, common Q, capital R, common R. Everybody cool here? Everybody good?
Yes, sir.
All right. Let's look at right angle triangles now. The sides of a right angle triangle have special names. When naming the sides, it is quite convenient to firstly name the hypotenuse, since it is the only side that is fixed. The other two sides are named in relation to the acute angle being considered, and these are named after the said angle is identified. So let's look at the diagram here. So the hypotenuse, remember the hypotenuse is always the longest side of a triangle. Why? Because it is always opposite the largest angle, right? Now with reference to the acute angle, let's call it theta in this case, A is the side, at A, so theta is at A here, then side BC is called the opposite. Wherever the acute angle is, the side that it's facing, which in this case is BC, it's called the opposite. Everybody okay? So once you have identified the hypotenuse and the opposite, the remaining side is called the adjacent angle. And it is the angle, not adjacent angle, what am I saying? It's called the adjacent side, and it is always opposite, what am I saying? Oh my God. So the third side, AC, is called the adjacent side, and it is always next to the angle theta. Everybody good so far? Did I confuse anybody? I know I was eating up my words. I'm very sorry about that. I've been doing that all morning. Anybody wants it re-explained? Say no. Okay. So let us consider another right angle triangle PQR with an acute angle theta at Q over here. We use the same principle outlined to identify and name each side. So again, this is the largest angle. Opposite the largest angle is called the hypotenuse. This is the given acute angle. So the side that is facing this is called PR, and it's called the opposite, and the adjacent is whatever that remains. Yeah? You all have any questions? Hello?
No, sir.
Okay. Solving a triangle means we must be able to determine the values of its elements. Triangles have 6 elements, which include 3 sides and 3 angles. A triangle is specified by the 3 elements, and we need to be given to solve for the remaining elements a minimum of 3 elements to solve for the remaining ones. These 3 elements that specify a triangle can be any of the following combinations. First one, two sides and the angle included by the two sides, two angles and their common arm, three sides, and a right angle, hypotenuse, and one side. Now, the Pythagorean theorem, I wouldn't go into that because we already did that when we did triangles, so I'm not going to go into that. But basically, the square of the hypotenuse is equal to the sum of the square of the other two sides. That is the Pythagorean theorem, right? What is most important is the trigonometric ratios, right? So introducing trigonometric ratios. The trigonometric ratios are useful when finding the unknown side of a right angle triangle. When we study triangles, we learn that two triangles are similar when all their corresponding angles are the same. We did that when we did congruent triangles and congruent shapes. You all remember that lesson? Yes, no? Yes, people?
Yes, sir.
Right? So the three sides below have the same angles, but they differ in size. These triangles are similar from the property of similar triangles. We can also deduce that the ratio of their corresponding sides is the same. Let's see what I'm talking about here. This is what I'm talking about here. Everybody seeing it? They are different sides, but their ratios are the same. As you can see here. The ratios of the corresponding sides. Okay? Now we did all of this when we did congruent triangles, so I'm not going to go through this. Right? What is most important is the trigonometric ratios. So let's do this. For any given right angle triangle, the ratio of pairs of the sides is constant. There are really 6 possible pairs, but 3 of these are the inverse of the other pairs. For example, we can pair side A with side C in 2 ways. We can have C over A, or we can have A over C. The ratio C over A is the inverse of the ratio A over C, and vice versa. Say what again, David? Okay. The ratio C over A is the inverse of the ratio A over C, or vice versa. So in the right angle triangle ABC shown below, we will only be concerned with the names of the 3 ratios, A over C, and B over C, and A over B. These ratios are called trigonometric ratios and will be defined with reference to the acute angle A is equal to theta degrees. Now, this here in the orange is the most important thing. So I want you to take a note of that. Write it down quickly, please. Just the ratios, right? Sine theta is equal to opposite over a hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. I'll show you an easy way to remember it. Are you all finished taking it on? You all could at least answer, you know.
Yes, sir.
All right. So are you all seeing this here?
Yes, sir.
Right. So Sohcahtoa. Sohcahtoa is one of the easiest methods and is the most commonly used method by teachers to remember the trigonometric ratios, right? Sohcahtoa. Sine, cosine, tan, and then opposite over adjacent, as you can see here. Adjacent over hypotenuse, as you can see here. And opposite, or sorry, adjacent over hypotenuse. And then toa, which is tan, is opposite over adjacent. Right? Another way you can remember it, once you know it's sine, cosine, and tan, another easy method that some students told me about in the past is, oh heaven, another hour of arithmetic. Right? Once you know it's sine, cosine, tan, once you know it's that order, all you simply have to memorize is, oh heaven, another hour of arithmetic. Everybody cool? Joshua, you're gonna have to wait until the video comes out then, right? Because the handout is a pretty big handout and I can't take too much time stressing on one, right? And of course, you all know you can get the handout on Fast Maths. So that will help you all if you miss anything, right? So is this okay? Are you all finished taking it down?
Yes, sir.
Okay, let me switch back. Let us see in this example here. Calculate the value of y in the triangle shown. Let us see what we are given here. So we are given the hypotenuse, as you all can see here, it's 8.2. And the unknown side is adjacent to 41.2. So in other words, we are given the hypotenuse. We need to find we are given the hypotenuse and we need to find the adjacent, right? So which one of these sign rules deals with hypotenuse and adjacent? Which one deals with hypotenuse and adjacent? This is opposite and hypotenuse. This is adjacent and hypotenuse. This is opposite and adjacent. So which one deals with hypotenuse and adjacent? Anybody? Yes, David, correct. Cosine. So hence the reason we are using cosine. And remember, the formula is cos theta. And in this case, theta is 41.2 is equal to y over 8.2. So let me just show you how we work out that, right? So it's cos theta over adjacent over hypotenuse. So it's cos 41.2 is equal to adjacent. In this case, the adjacent they give us is y over the hypotenuse, which is 8.2. Everybody good? Now, if we want to find y, we have to make y the subject of the formula. So we're just taking this, which is division, it goes across. We get cos 41.2 multiplied by 8.2 is equal to y. So here you will take your calculator, right? And you will write cos, you press cos, so press cos, and you put 41.2, and then you will get this long figure here, and you just multiply that by 8.2, and you will get 6.17 approximate 2 decimal places, right? 6.17 approximate to 2 dp. Any questions there? Okay, thank you, David, for answering. So let's switch back to the handout now. I want you all to do this one for me. Example 2, I want you all to try that one for me. I'm giving you all 2 minutes to do that one. Can anybody first tell me which rule we are using? Which one of the trig ratios we're using?
Is it sine?
Yes, correct. We are using sine because we are asked to find the hypotenuse and we are given the opposite. And as you all can see, so again, we are given the hypotenuse and we have to find the hypotenuse and we are given the opposite. So hypotenuse and opposite. Only sine deals with hypotenuse and opposite, right? You have to look at it in terms of that, and that will help you to determine which rule, which rule you are using, which trigonometric ratio, you are using. Everybody good? So yes, we are using the sine rule. All right, so can we work it out now? So remember, it's sine theta over, which is equal to the opposite over the hypotenuse. So sine, in this case, it's 24 degrees. So sine 24, opposite is 6.3 over hypotenuse, which is x. So we really want to find out what is x. Agreed? Yes, no?
Yes, sir.
Okay, so what do we do here? In a case like this, we can cross multiply because the x is to the bottom here, right? It's not to the top, where we can just easily fling across the denominator. So we have to cross multiply. So we get sine 24 multiplied by x, of course, is equal to 6.3 because 1 by 6.3, right? So we don't want sine 24 here, we just want x. And since multiplication is taking place, we carry it across. X is 6.3 all over sine 24. Okay? On your calculator now, you will say 6.3 divided by sine 24, and you are supposed to get 15.4, let's say 49 to 2 decimal places. Any questions there? Anybody confused? Okay, so Joshua, sine theta is equal to opposite over adjacent. And in this case, they give us the angle as 24. So sine theta, which is 24, is equal to 6.3 over x. Since the unknown is to the bottom, we can't just take this and fling it across here because that will give us an incorrect answer. So we have to cross multiply. So sine 24 multiplied by x is equal to 6.3 by 1, which is equal to 6.3. And then that's why I didn't put it multiplied by 1 here. Now we don't want sine 24 multiplied by x, we just want x. So since multiplication is taking place here, I'm taking this across. So it will be 6.3 divided by sine 24, And your calculator, you'll just put in 6.3 divided by, you press sign and 24, and you will get 15.48 something, and I'm approximating it to 15.49. Okay? Yeah, no problem. So let me just kick it up a notch a little bit. I want you all to try this question here for me. Calculate the size of angle alpha to the nearest 0.1 degrees. So in other words, they're asking you for the nearest tenth. So can anybody tell me which ratio we are using here?
Sign again.
Yeah, why?
Because you're given the hypotenuse and the opposite.
Correct. So you are given the hypotenuse and the opposite, and you are asked to find the angle. So let me do this one for you all, right? Let me try this. Let me do this one for you all, because I know some people will be confused, right? So we're using sine, theta. We don't know what theta is, right? Actually, we do. They tell us theta is alpha, but we don't know what is alpha, right? Is equal to opposite over hypotenuse. So sine alpha is equal to the opposite. In this case, it's 3.6 over the hypotenuse, which is 5.72. Everybody good?
Yes, sir.
All right. So how do we go? What is the next step from here? Anybody? Okay, so let me tell you all, let me give you all a hint here. Whenever you have to find the angle, it's always the inverse. So sine inverse of 3.6 over 5.72. Okay? So let us see how we're doing that now. So we want sine inverse, right? But as you can see, it's sine here. So if we want inverse, you have to press second function, sine, and you see we get sine to the power of -1 there. I hope you all are trying it with your calculators, right? Let's try it back. Second function, sine. Okay? And now it's 3.6 over 5.72. So you open a bracket, 3.6 divided by 5.72, close bracket, and you will get 39.00. And we want our answer to the nearest 0.1. So that's here, right? That's the nearest tenth. So our answer is 39.0. Any questions there?
So
Yeah.
I feel like something wrong with my calculator because my calculator, because I do it exactly where it says to type in and I get something totally opposite.
Okay, when you press sine, when you press second function sine, are you getting this here?
Yeah.
Right, and then you open a bracket. 3.6.
Yeah.
Press divided. 5.72 and close bracket.
Yeah.
Did you open a bracket here?
Yeah, I did.
Okay, and you still get a different answer?
Yeah.
I have no idea what's going on.
It's not open to promote it because he went to Saudi Arabia and so on.
What answer are you getting?
I get 0.68.
Okay, is your calculator on degrees, radians, or gradient?
So what?
You're supposed to see DEG.
Yeah.
Are you saying DEG?
No.
What are you saying?
RAD.
Right, that's why your answer is incorrect. So you're saying this TRG button here in your calculator?
Yeah.
You need to press it until you see DEG comes up on the top.
Okay.
Right, and now try it and see if you get the same answer.
Okay.
Where capitalization is concerned. Treasury management, governance.
Okay.
Okay, great.
Thank you.
No problem. Let's see another question. I want you all to try example 4 on your own. And somebody will share the answer for me. First of all, which trigonometric ratio are we using?
Tan?
Tan, yes, and why?
Because you're given the opposite and the adjacent.
Correct. And for those of you who are confused, remember opposite and adjacent. So we're using T, which is tan, right? Just remember Sohcahtoa. So we're using opposite and adjacent. That's why I made you all write on this. As soon as you all get the answer, tell me, right? Correct, Johnson. So let's see how we work this out, right? So it's tan alpha is equal to the opposite over the adjacent. So tan alpha is equal to 3.7 over 5.62. Okay? So more or less, if we want alpha, I didn't show you all this before, but I'm doing it now, right? If you just want alpha, it's when tan goes across, it becomes tan inverse of all of this, 3.7 over 5.62. You could have done the one before like this too as well, right? So on your calculator, you will press second function tan, open brackets, 3.7 divided by 5.62, close brackets, and you would get 33.4 to one decimal place, or if you want to put 33.6 to two decimal places, that's perfectly fine. Oh wait, no, they set to the nearest 0.1, so right. So the nearest 10th, right? That's 1 over 10. Any questions there, guys? Say no more for about hold your peace. Everybody understanding so far? Okay, great. Let's look at example 5. I want you all to try example 5. I'm giving you all 2 minutes for that. And then we're going to be looking at the cosine rule, the sine rule, etc. Now, in this case, as you can see, we have to find the hypotenuse, right? Now, you can use the Pythagorean theorem here, if you so desire, or you can use trigonometry if you want as well. The easier thing to do is to use the Pythagorean theorem, right? Okay, can we correct? So let's see here. H is the hypotenuse, right? So h squared is equal, well, h represents the hypotenuse, right? H squared will be 4.5 squared plus 2.8 squared. 4.5 squared is 20.25 plus 2.8 squared is 7.84. So h squared is equal to 28.09. We don't want h squared, we want h. So you have to find the square root to cancel with the squared. When you do on one side, you have to do on the other side because remember, it's all about balance, right? So we get h here. And of course, the square root of 28.09 is 5.3. Okay? Any questions there? You all got that?
Yes, sir.
All right. So I'll leave it up for a minute for those who wish to take it down. Okay, I'm taking it off now. Let us go back to the handout now. Okay. So solution of non-right angled triangle. So the above section dealt with solution of only right angled triangles, but these ratios cannot be applied to non-right angled triangles, right? So we will now explore two rules that will be used for other triangles. The choice between the two depends on what combination of three elements is given. So again, the trig ratios can only be applied to right angle triangles. If you do not have right angle triangles, you have to use these two rules that I'm going to give you all, and it will be dependent on the combination of three elements that they will be giving you. So the first one is the cosine rule, right? Now you all don't have to memorize this, it is in the formula sheet. Let me just double check that. Yes, it is in the formula sheet, but seeing as this year your multiple choice exam is going to be online, I don't know if you all are going to get a formula sheet. I don't know how the exam is going to run, okay? So I don't want to tell you all to memorize it, and then it comes in the formula sheet, and then I don't want to tell you all not to memorize it, and they don't give you a formula sheet, right? But let's see how we will remember this. The sine rule. A over sine A is equal to B over sine B is equal to C over sine C. Everybody good? Just remember ABC on the top and sine A, sine B, sine C on the bottom. Right? It's a very easy way to remember. Now, when using the rule to find an unknown side, we must be given any three parts of the ratio. A and sine A, B and sine B, or A sine A, C sine C, or B sine B, C sine B. Everybody comfortable with that so far?
Yes, sir.
All right. Let's look at the cosine rule now. In some instances, we are given three elements, but they do not allow us the setting up of the sine rule. For example, if we need to solve the following triangle, there are no matching pairs of sides to angles given. Are you all seeing that? We have the sides, right? But they do not match up to an angle. Only A is matching up to this here. You follow? Yes, folks?
Yes, sir.
All right, so let's see in this case what we have to do. So A squared is equal to B squared plus C squared, which is the hypotenuse formula, right? Minus 2BC cos A, or B squared is equal to A squared plus C squared minus 2AC cos B, or C squared is equal to A squared plus B squared minus 2AB cos C. An easy way to remember this, BC, BC. All of them is minus 2, minus 2, minus 2, right? So if it's BC here, then it's BC here. If it's AC here, then it's AC here. If it's AB here, then it's AB here. And it's always cos whatever is in the front here. So if this is A, it's cos A. If this is B, it's cos B. If this is C, it's cos C. Everybody cool with that?
Yes, sir.
Now trigonometry it's kind of difficult, but it could be very easy. That's why I chose it to teach at the end, because I know a lot of students have problems with it. So I chose it at the end because I know it will take a long period of time to finish. So that's why I wanted to complete other topics and not focus too much on trigonometry. And at the same time, I didn't want to rush it as well. It's all about memorizing your formulas and understanding where and when you have to use them. That's a key to passing trigonometry. Now let's look at an example here. Calculate the size of angle ACB. What do we do here? Which rule are we using? Huh? Anybody? In this case, we are asked to find an angle, so we're using the sine rule. No, Jada, we're using the sine rule. All right. So let's see. Let me just open this on Microsoft Paint. Okay. Everybody's seeing this here, right? Yes, no feedback would be nice from you guys. All right. So as you can see, this is matching up. Oh God. This is matching up with this. And also, C is also matching up with 6.5. Everybody good?
Yes, sir.
And also, this is B, this is C, and this is E. So B over sine B is equal to C over sine C. Agreed? Agreed, people?
Yes, sir.
Right, thank you for answering. You'll get me annoyed and not answering in class. So 7.6 all over sine, and what is B? And 42? So sine 42 equal, what is C? 6.5 all over, we don't know what sine C is, so we just write back sine C. What is the next step? Anybody can tell me what's the next step? Anybody? We cross multiply, right? So as you can see here with the arrow, it's 7.6 multiplied by sine C is equal to 6.5 multiplied by sine 42. Any questions so far?
No, sir.
Okay, so let me just, I write back this here, right? So 6.5 multiplied by sine 42. And of course, we are carrying this across. So when that goes across, it becomes division. So 7.6. And what remains is sine C. So sine C is equal to that. Excuse my handwriting, please. So 6.5 multiplied by sine 42 will give us what, people? 4.34934891 if you use a calculator, you will find out, divided by 7.6, which will give us 0. Guess what? I think I'm writing too big. It'll give us 0.5722 or 0.572, right? But we don't want sine C. What do we want? We want to find out what is C, which is this part here, right? We want to find out that angle. So we take in the sine, we carry it across, we left with C, and remember, once it goes across, it becomes sine inverse of 0.572. Okay? So on your calculator, second function, sine 0.572, and this will give us 34.89. Correct, to 2 decimal places. Anybody wants it redone? Stay now.
So you can write over, like the one in the top in the corner.
Okay, no problem. Right, so sine C is equal to 6.5 multiplied by sine 42 all over 7.6. Better, Jada?
Yes, it is.
All right, I'll give you all a 3 minutes. I'll take it down. Can I take it off now?
Yeah.
when you talk.
Okay, try this question for me, people. Giving you all 5 minutes to try that, right? Joshua now seen the answer. Yeah, you're correct. So let's see how we're doing that then. Obviously, we know we are using the cosine rule, right? Because we have to find a length, right? So as you can see, opposite capital A is small a, opposite capital C is small c, and opposite capital B is small b. Okay? So c squared is equal to a squared plus b squared minus, and the reason I'm using this is because we are given a squared and b squared, and we have to find c squared. That's why I put c squared in front. We have to find c squared, right? So minus 2ab cos c. So we don't know what c squared is, so we just write c squared is equal to a squared. We know a squared is what? 8.4, agreed? So 8.4 squared plus b squared, which is 7.2 squared minus 2 into a, which is 8.4 into b, which is 7.2 cos c, and as you can see, cos c is 31.4. I can't write it in there, so I'm just going to type it in, right? Right? So cos 31.4. So we will use our calculators and we will see how to figure it out. So c squared is equal to 8.4 squared. 8.4 is how much? Squared. That will give us 70.56 plus 7.2 squared is 51.84. And in our calculators, you will write 2 open brackets, 8.4 close brackets, you open the next bracket, 7.2, you close the bracket. So you will get 120 cos 31.4. So 120, sorry, you'll get 120.96 cos 31.4. So in your calculator, you will press 120.96 cos 31.4, and this will give us 103.24, you could say 6 if you want, to 3 decimal places. And of course, let's add this, 70.56 plus 51.84 will give us 122.4. So 122.4 take away 103.246 will give us 19.154. But that's c squared, but we don't want c squared, we want c. So to get rid of a square, you have to find square root. So this square root cancels with this square, you get c is equal to, and the square root of 19.154 is 4.37, if you want to leave it like that, or 3.77 to 3 decimal places. Everybody good?
Yes, sir.
Any questions so far? Y'all want a short break? Okay, take 10 minutes break. We start back at 2:19. Can y'all just remind me to click the recording again, just to continue the recording? I'm pausing it right now. Thanks, David. Yeah. All right, so let's now look at some applications of trigonometry. Okay, so we will now examine how we can use trigonometry to solve problems in the real world. We will relate to objects in the physical world, to positions in three-dimensional space, and use trigonometry to calculate unknown distances between 2 points in a plane or 2 points in space. In the following section, we will use triangles and laws of trigonometry to calculate unknown distances such as height of a cliff and the depth or breadth of an ocean. So let's look at angles of elevation and depression. So these angles are defined in relation to an observer who may be looking up or down at an object. So angle of elevation is obviously when the observer is looking up, right? So when an object is above, so let's look at angle of elevation. when an object is above the level of an observer, we have an angle of elevation. The angle of elevation, as seen by an observer, is the angle between the horizontal, as you can see with the line here, the horizontal, and the line drawn from the observer to the object, which is the line of vision. Sorry, the line of vision or sight. The angle of elevation, denoted by let's call it A, but it's alpha, is shown in the diagram. Everybody okay with angle of elevation? So this is the observer's eye level. This is the eye level of the person. So the person is watching straight in a horizontal way. And then that distance from the person watching the horizontal distance to the actual object, the angle between that is called, well, A in this case, right? That's the angle of elevation. Angle of depression is total opposite. When an object is below the level of an observer, we have an angle of depression. The angle of depression, as seen by an observer, is the angle between the horizontal, which is drawn in the line with the observer's eye, and the line drawn from the observer to the object, which is the line of vision or sight. The angle of depression is denoted by theta degrees, as shown in the diagram. Let's see the diagram. So as you all can see, the observer's eye is here, and below the level of the observer's eye is the object here. This angle here between the horizontal eye level and the object level is called the angle of depression. And this, of course, is the line of sight. Any questions so far? Joshua, you okay? Joshua? Okay, great. Let's look at the relationship between the angle of elevation and the angle of depression. Both the angle of elevation and the angle of depression are measured from the horizontal drawn from the observer. If the observer is at A, looking up at the object at B, then there is an angle of elevation. So if the observer is here, looking up at B, then that's angle of elevation. If the observer is at B, looking down at the object A, then that's an angle of depression at B. Everybody following so far, right?
Yes, sir.
All right. So the angle of elevation of B from A is X degrees, as you all can see here. The angle of depression from A to B is also X degrees here. These angles are equal because they are alternate angles. And remember, when we did angles, we said that Z angles or alternate angles are equal. So whatever angle we have here is the same as angle here, which is X. Okay? So a typical problem on angles of elevation and depression involves calculating distances at angles within a right-angled triangle. So let us see here what I'm talking about. An observer situated at point A on the top of a vertical cliff of height 50 meters looks down, so that's angle of depression, looks down at a steamer located at point B, an unknown distance away from the base of the cliff. The angle of depression of B from A is 24 degrees. Calculate the horizontal distance between the object and the base of the cliff. Now let's see how we will do that if we were given it, right? Let me put them side by side so you will see what I'm talking about. Just give me a minute here. Let me just snip it. Right, let me just pull it up now for you on the screen. Right. Everybody can see this here, right? Okay, great. So the observer situated at point A, this is where he is at, right? Point A. Let me just, all right, he's at this point here, point A, on the top of a vertical cliff. Vertical means going down, right? Of height 50. So let me just, so this is the top of the cliff, right? Top. The observer is looking down at the vertical cliff of height 50. So he's looking down, so it's going down, and it's 50 meters, of course. Located at point B, he's looking down at point B, and the angle of depression of A, so that means this is point A here, right? The angle of depression is 24. So he's looking down at B. This is point B here, right? And it's saying that this is 24 degrees from the base here. Everybody understand how I get that, right? Any questions? Okay, I assume a silence. I'm taking a silence to be no. Okay, so let's see what we also have to do. Calculate the horizontal distance between the object and the base of the cliff. So if this is 24 here, if this is 24 here, if we were to draw this here, as you can see, we have a Z angle being formed, right? Let me just trace the line so you will see it. Right, you all see that Z angle being formed there? So that means that here is also 24 degrees. Yeah? And the distance from here to here is unknown, we don't know it. So we'll call that X meters. Are you all following?
Yes, sir.
All right, so let's redefine print here now. So since the cliff's vertical distance, angle ABC, so it's C we're talking about, which is this point here, is equal to 90 degrees. So let's make it known as a 90-degree angle. The angle of depression, 24 degrees, is here. It's shown at the top of the cliff. Over here, sorry, I mean, the angle of depression here is 24. Consider the triangle ABC, where ABC is equal to 24. So in other words, angle B is 24. Remember, it's the angle in the middle I'm talking about here, right? So as you can see, it's 24 degrees because it's an alternate angle. You follow? So here is the 24 degrees because this is the angle of elevation here. This is 24 degrees. So because of alternate angles, here has to be 24. I did it the opposite way. So I apologize for that, right? So this is the top. Angle of elevation is 24 degrees down. So because of alternate angles, here is also 24, right? Then the distance between the object B and the base of the cliff be X. So that's what I did here. We are given the height of the cliff, which is AC is 50 meters, and we wish to find X. With reference to angle ABC, the side AC is opposite and the side BC is adjacent. Are you all seeing that? This is opposite and BC is adjacent. This is adjacent. So we have to use tan because tan is the only one that considers opposite and adjacent. So tan 24 degrees is equal to 50, which is the opposite over the adjacent of X. Now, we don't want, we just want X, right? So when we make X the subject of the formula, of course, you're also supposed to know how to do working by now because we did some examples prior to this, and this is basic algebra. We will get X is equal to 50 over tan 24 degrees. So that will mean that, of course, you will take a calculator and you will put 50 divided by tan 24, and you will get 112.3 meters. So the distance between the object and the base of the cliff is 112.3 meters. Any questions so far? All right. Let's look at another example then. Angle of elevation of the sun. The angle of the elevation of the angle of elevation of the sun is the angle between the horizontal and vertical line of vision if one is able to look up at the sun. We usually measure this by erecting a vertical pole and measuring the length of the shadow as shown in the diagram below. So let's see here. So this is the pole. This is where the observer will be. This is the angle of elevation here, right? And this is the observer looking at the sun. Yes, people? And of course, this will be the shadow here. So the shadow of the pole, you put up a pole, and where the shadow of the pole begin will be here, and where it ends is where the person will be standing. So the person will stand up here, they will look up at the sun, right? And that the distance here, where they're looking up at the sun, and the distance here will give you the angle of elevation. Any questions there?
No, sir.
All right. So I want you all to try this question here for me then.
Sir David, want to know if you could re-explain it?
What are yes? The sun? Oh, sorry, I didn't read a message. I was busy writing down something here. So this is a pole. If you want to know the angle of elevation from where a person standing to the sun, more or less, just you could erect a pole, right? Or you could just go stand in front of a pole, a flag pole, or anything of the sort, right? In CXC, they like to use flag poles apparently. So you stand in front of the pole, right? This is the pole here. The sun will be over here. So obviously the sun will cast a shadow against the pole, and the shadow will start from here and it will end here. Where the shadow ends, you will go and stand here, and you will look up at the sun over the pole, and the distance from your eye level from where you are standing to the pole, that distance from there to the ground, which is where the shadow will be cast, will be the angle of elevation. So I believe you all will be catching it here with this example here, right? So let me reveal the solution for you all, and we'll work it out together. A tree 50 meters tall and standing at a right angle to the ground casts a shadow of 60 meters. Calculate the angle of elevation of the top of the tree from the furthest edge of the shadow. So let's look at the solution here. Let A, well, you'll call it A, right? But it's already alpha. Let A be the angle of elevation of the sun. The diagram shows the height of the tree and the length of its shadow. So this is the height of the tree, 50 meters, and this is the shadow, 60 meters here, as you can see here. Okay? So the top of the tree to the end of the shadow will form angle A here. Everybody good so far?
Yes, sir.
5% is
All right. So with reference to alpha, the opposite and adjacent side of a triangle are 50 meters and 60 meters respectively. So since we know we are given the opposite and we are given the adjacent, we know we're using tan. But we have to find what is the degrees, right? So it's tan theta degree, sorry, tan alpha degrees, we'll call it A, right? So tan A degrees is equal to 50 over 60. So we're taking this tan and we're carrying it across. So when we carry it across, we'll get tan inverse of 50 over 60. And of course, you know how to get tan inverse, second function tan. And you just open a bracket, 50 divided by 60, close brackets, and you will get 39.80 or 39.8 to the nearest tenth, of course. Do you all have any questions so far? Yes, no? Okay. Let's look at this diagram here then. The diagram, not drawn to scale, shows a vertical tower FT. So here we have FT of height 25 meters. 3 points are F and T are on horizontal ground such that R is due east of F and the angle of elevation of T is 27 degrees. So that's over here. Due south of F and SF is 43.3. You are asked to calculate the length of RF and SR, and you have to write it correct to 1 decimal place. And you are also asked to calculate to 1 decimal place the angle of elevation of the top of the tower from S. So let's see here our solution. So since we know that RTF is a right angled triangle, because FT is a vertical tower, so we're splitting it up. We're splitting it up here, right? We're taking out this triangle here, FTR. So we know the angle of elevation was 27 degrees. So we're using tan. Why are we using tan? Because we were given the opposite and the adjacent, right? Well, we have to find the adjacent, sorry. So tan 27 is equal to 25 over RF. But we need to find RF. So we know we have to carry this across, and of course you all know how to do the transposing already because I taught you all that. So you will get 25 over tan 27. So in your calculators you will write 25 over tan 27, and you will get 49.1 meters. Okay, it's basic calculations. You just use a calculator here. Of course, I will send you all the homework for this topic. Right, I will send you all some past papers to try for me, and we'll correct it next class, right? Just make a note of that. Right. So next, in triangle SRF, R is east of F, right? This way is east here, and S is south of F, which is here. And angle SFR is a right angle. So we are given SF and we calculated RF above. So we can use Pythagoras theorem to find here. This is the hypotenuse, of course. Let's look back at the original diagram. As you can see. So the square of the hypotenuse is equal to the sum of the square of the other two sides. So of course we square this and we square this and we'll get this answer here. And to get rid of the square, we have to find square root. So we find the square root of the side. What you do on one side, you have to do on the other side. Okay? So we will end up getting 65.43. And if you want to write it correct to one decimal place, it's 65.4 meters. Again, it's practice, practice, practice. You have to keep practicing, right? Let's look at the final part of the question. To calculate the angle of elevation of the top of the tower, let's call it T, from S, we need to draw the triangle TFS and insert the angle of elevation. We know that this triangle is a right angle, as T is a vertical tower, and we know that the length of the sides FT and we know the length of the sides FT and SF. So we will use tan. Why? Because we are given opposite and adjacent, right? We just found the adjacent. Sorry, no, we are given adjacent here. So yeah, so 43.3 and 25. So if we want to find this, we want to find A. We take across tan and it becomes tan inverse into 25 over 43.3 and we'll get 30.00 or 30. You all have any questions? I know some of you must be confused or tail, but you just have to practice, right? It might make more sense to you all when I teach through the past papers next week. Next week I will be correcting the past papers and I will be teaching through the past papers, more or less. So it might make more sense to you next week, not to worry, but please try to do the past papers that I will be sending for you all. I will send some multiple choice questions and I will also send some paper 2 questions for you all to try, okay, just a few. It's nothing difficult, don't worry too much, and if you're having any problems with solving the problems, you can consult Fast Maths, right? So let's move on to our next part of trigonometry called bearings. And when we are finished with this, that will be the end of class, right? Y'all thinking the next break or you all good so far? We'll finish around 3:30. Even though I gave you all the break. You want the next break or you all good? Okay, I'll give you all a 5 minutes break, right? Just take a 5. If you're all still confused about this topic, you can log into the Monday class. Just message me Monday morning and I will give you the code to enter the Monday class. And I will be doing this again because for some strange reason, every class I explain things differently. So you never know, you might pick it up there and if you didn't pick it up here, right? And of course, the Monday class has a lot of students and they ask a lot of questions. So it might have you might have some doubts in your mind about the topic and it might be addressed in the Monday class. So again, if you all want to join the Monday class, just let me know, message me Monday morning. I have class for 9 o'clock, just message me before and I could let you join the class, right? Okay, let's see. So in our study of trigonometry so far, we have been calculating unknown distances in triangles. If we were given certain elements of a triangle and used either the trigonometric ratios or the sine and cosine rule to solve for any of the elements of the triangles, what should I say them? We were given certain elements of a triangle and used either the trigonometric ratio or the sine and cosine rule to solve for any of the elements of the triangles. In the application of trigonometry to real-world problems, we will now learn to use angles to describe the position of one point with reference to another. Often in navigation, it is necessary to determine the relative position of objects and to calculate the distance of journeys. The rules we learned in trigonometry can be applied to solve problems involving both directions and distances. We use bearings to tell the direction of one point from another. Now we will compare how bearings relate to the 4 cardinal points. You all know the 4 cardinal points, right? So bearings and the 4 cardinal points. The 4 cardinal points are east, west, north, and south. We often use it to describe the position of one place on a map in relation to another place. So for positions that fall exactly between any 2 cardinal points, say between north and east, we use northeast, which is NE. And between south and east, we use SE, which is southeast. And between south and west, we use SW, which stands for southwest. And between west and north, we use NW, which stands for northwest. The diagram below shows these directions. Everybody okay? Okay. Using the cardinal points, we can also describe the position of points that do not fall on exactly on any of these 8 points. To describe the position of points P and R from the origin, we follow the conventions shown below. So since P lies closer to north, this is P here, right? And this is R, this is what I'm talking about here, P and R. So since P lies closer to north than east, as you can see here, it lies closer to north. The angle measured from the north is 20 degrees, of course. Therefore, the direction of P is 20 degrees east. Sorry, direction of P is N 20 degrees east. That's how you write it in bearings, right? Sorry, in this form. So let's look at R. The point R is closer to east than north, which is N. The angle measured from north is 20 degrees. Therefore, the direction of R is E, 20 degrees north. You all catch the drift? Or anybody want me to repeat it? Re-explain.
So we good. Okay.
All right, David, want me to repeat it? So since this is the distance between N and P, and it's 20 degrees, right? It's closer to north. So the direction of P is N 20 degrees east. And let's look at R, where it is here, it's the opposite. The direction of R is E 20 degrees north, right? Because this is the eastern side here. Okay, no problem, David. So although the cardinal points are widely used, no problem. Although the cardinal points are widely used, there is a measure of direction which does not refer to any cardinal point, only an angle. This measure is referred to as bearings. If we were to describe the 4 cardinal points using bearings, then the directions will be read as shown below. So north is read as 0, 0, 0 degrees. East is read as 0, 90 degrees. South, 180. West, 270. Any questions so far? You all might want to make a mental note of this, right? All right, let's continue. The northeast, northwest, southwest, and southeast directions would be described using the following. So northeast, okay, so this is north here, right? This is east, so this is 90 degrees. So between 0 and 90 is 45 degrees, obviously. So 90 and 180, between 90 and 180, if you add 45 degrees, so every slice here, think of it like a pizza. Every slice is worth 45 degrees. So 90 plus 45 will give us 135, and that's how I'm here. So 135 plus 45 will give us 180, which is here, right? Then 180 plus 45 is 225. 225 plus 45 is 270, and of course 270 plus 45 is 315, and of course 315 plus 45 is of course 360. Any questions so far? Okay. So let us now that you have all of that, let us now define a bearing. A bearing is a direction measured from north in a clockwise direction and is given only by an angle. Bearings must always be written using 3 digits. So for angles less than 100 degrees, we place a 0 or zeros in front of the number to ensure that there are 3 digits. So for example, north is on a bearing of 0, 0, 0 degrees. Northeast is on a bearing of 0, 4, 5 degrees. So it must have 3 digits. Make sure you remember that, right? Let's look at measuring bearings. How do we measure the bearing of one point from another? So consider 2 points. Let's say we're considering A and point B. We are interested in finding the bearing of A from B. Again, A from B. So B is the starting point. This means that if a person is at B, he wants to know what is A's bearing. Sorry, he wants to know what A's bearing is from him. That's an error here, right? So that's supposed to have is here. We can also say what is A's direction from B. Now, in solving problems on bearings, it is recommended that we set up a compass at each of the 2 points we are interested in. In this case, at A and B. Next, we join the points A and B. Now we can measure direction from B by identifying the angle between the north line and the line segment measured in an anti-clockwise direction. Let's see what I'm talking about here, because I know some of you might be confused. So we are given the points A and B as shown here. So we set up a compass at A and B and we join the line. So you draw a compass here, the cardinal points here and the cardinal points here, right? And then join A to B. So the angle that the line AB makes with the north line at B is the bearing of A from B. This is shown This is shown by theta degrees in the diagram. So A is naught. So from naught to where it is here, as you can see, is how much degrees? Anybody can tell me? Okay, you're all very quiet. So here now, if we were interested in the bearing of B from A, then we would follow the same steps, but the angle is measured at point A instead of point B. So we're measuring it here. Okay? So it'll be measured from naught to here. So it'll be 90 plus 45. And this one it would have been 180 plus 90 plus 45, which will give us 315. Okay? Somebody message? Okay. So you all kind of understand this?
So not really.
I wouldn't go into
About the whole thing?
much detail.
Yes,
about
please.
No
these
problem.
models.
We are given the point A and B as shown. So let me read back the question here. Consider 2 points, A and B. We are interested in finding the bearing of A from B. This means that if a person is at B, he wants to know what is A's bearing from him. In solving problems on bearings, it is recommended that we use a compass to measure this. So let's go to the diagram now. So we have 2 points, A and we have B. So if you draw a compass here across for the cardinal point, right, from north, we will be measuring from north, right? So first set up a compass at A and B, which is what we're doing here. Then we join A to B. So from the north line, we're measuring till this line here. Okay? So 90 plus 90 plus 90 is 270, and 270 plus 45 is 315 degrees, right? So the angle here will be 360 degrees. 315 degrees, sorry. Now, if we were interested in finding the bearing of B from A, we will follow the same steps, except we'll be measuring from A instead. So we'll measure from the north line to where it touches the line here. So it will be 90 plus 45 degrees. Understand? So we'll
Yes.
get 135. That being said, I want to give you all a question here to try. I'm giving you all 10 minutes to try this question, so please try it. Meanwhile, let me see if I can organize some past papers here for you all on bearings. You all finished? So what did you get, David? Anybody want to share the answer? Okay, I guess nobody want to share anything. So let's see the answer then. So the bearing of P from Q is 120. That's what it tells us in the question, right? So we put Q here and we put P here, right? Because that's what we want to find from Q to P. So Q and P here. So we connect the point, and since we want to find from Q to P, we're looking at it here. So this is 120 according to the note. Sorry, the question. This is 120 from north to this line is 120, and as you can see, this is 90. So 120 take away 90 will give us 30 degrees. So that's how I got 30 degrees here. Okay, but we want to find from Q to P. So the bearing of Q from P is 300 degrees, of course. Note the bearing is measured at P. So over here, let's look at P now. So 90 plus 90 plus 90 is 270, and 270 plus 30 is 300. Y'all follow? Johnson, you good? Johnson there? Johnson, you good or you confused? I guess Johnson is not there. Probably fall asleep. All right, so let's look at some past papers then. The first one is from May, June 2015. Let me give you all let me find the question for you all. And I'll tell you all the answers, right? Which is the question here? All right, this is a trigonometry question here, number 54. Sorry, number 57. So in the triangle not drawn to scale, angle BAC is equal to 30 degrees and AP is equal to 40 meters. The length of BC in meters is, anybody can tell me? Anybody? No, David? Yes, I just see somebody message me A. Yes, A is the answer. 40 sine 30. Okay? Now these questions repeated, so you all need to pay attention to the answer. 40 sine 30. And why do we use sine? Because we're given the opposite. Sorry, because we're given the hypotenuse, right? And we are asked to find the opposite. So with the only other one that uses opposite and adjacent, sorry, opposite and hypotenuse is sine. So I'm using sine, right? So it's 40 and it's sine 30. It's always sine the angle. Sine or tan or cos the angle. The angle always goes after the sine, tan, or cos word. So it's 40 sine 30. Everybody okay?
Yes, sir.
Okay, since we borrowed.
I hope you're not just saying you're okay, just so that I can move on, right? All right, let's look at June 2016. Where is the question? Look at this one here, number 57. Everybody can guess the answer. So we're given the hypotenuse, and this is the opposite here, and we are asked to find the adjacent. In the right angle triangle above, which trigonometric ratio is equal to 4, 8? Anybody can tell me?
A ROE.
Correct. A, because it's sine. The sine ratio is the opposite, which is 4 over the adjacent, sorry, over the hypotenuse, which is 8. So the only one that will give you that is sine. So it's 57. I mean, it's A. Yes, folks?
Expense.
Yes, sir.
Okay. Even with
Right.
increased expense, we got a much bigger
Questions here. Right. Let's look at number 60. What do you all think is the answer for number 60? The diagram above, not drawn to scale, shows the angle of depression of a point X from Z. It's 30. If X is 10 meters from Y, the height of YZ in meters is? Anybody? Folks?
Okay.
So I'm not sure,
So
but saying it's A.
Yes, you're correct. The answer is A. 10 tan 30.
Yeah.
You are absolutely correct, yes. And let's look at our final past paper. Let's look at number 55. I don't know why it's highlighting in blue. Okay, so a ship sailed 8 kilometers. Just a minute, right? Right. A ship sailed 8 kilometers due east from A to B. Then it sailed 6 kilometers due north to C. Which of the following best represents the path of the ship? So a ship sailed 8 kilometers due east. So it's going 8 kilometers east. Look, we have one going 8 kilometers east here, 8 kilometers east here, and 8 kilometers east here. Then 6 kilometers due north. So it went north. Which one represents that? Anybody?
And I want,
B.
No.
to
It went from A to B. So A to B. And then from B, it goes to C. It goes not to C.
C.
Correct. C. Hey, Johnson, you wake up, girl. I was calling you just now, you didn't answer.
Wait, you was calling mom? My mom had called mom for something. Sorry.
Oh, yeah, I was calling you. All right. So I want you all to now do for me number 57 and number 59. I'll give you all 5 minutes to try and figure it out. How many of you would be interested in joining the Monday class just to get a more in-depth understanding of this topic? Anybody could say? It's from 9 to 12. Okay, Joshua, you'll just have to message me in the morning for the class, right? So number 57 and number 59, 5 minutes. Okay, you all have any answers for me? Number 57, what is the answer? Anybody?
So I see.
Yes, correct. It's C.
I have to put you.
And number 59, anybody? That's a repeat question.
You're not going to
Yeah, it was A.
but I want
Correct.
you to go through any.
So that will more or less be it for class for today. Right? Do you all have any questions? Let me just stop the recording. You all have any questions before I end?
No, sir.
All right.